Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. Current national and international fiber cabling standards refer to the use of mandrels when measuring optical loss on multimode fibers, and is thus an important part of multimode fiber testing. This video will briefly explain what a mandrel is, why mandrels are necessary, how to wrap a multimode reference cable around a mandrel, and how to implement a mandrel wrapped cable in a multimode fiber test. In the early days of fiber optic cabling standards, optical loss budgets were relatively large, in some cases up to 11 dB, and test results could afford a bit of uncertainty. However, as a result of increased bandwidth requirements, optical loss budgets became tighter and less tolerant of uncertainty. Thus, a mandrel, which is simply a smooth, even cylinder, was used to decrease the uncertainty of test results by filtering out unwanted modes of light from multimode reference cables. For clarification, a mode is simply a possible path that light can travel in an optical fiber. Multimode, as the name implies, carries multiple modes, usually numbering in hundreds. Some of these modes are useful for transmitting light, and others are not. Light traveling in low-order modes is useful because it travels at or near the center of the fiber core and is thus more likely to travel the full length of the fiber link. High-order modes, on the other hand, tend to occur near the core-to-cladding boundary. Because of this, light traveling in high-order modes naturally disappears into the cladding well before reaching the end of a fiber optic link. Eventually, all of the light traveling in high-order modes will be lost. When this happens, the fiber has achieved what is called equilibrium mode distribution, or EMD. For best measurement accuracy, the light being injected into the fiber under test through the reference cable should have achieved EMD. Unfortunately, multimode reference cables are usually only 1 to 5 meters long, which is far too short to fully remove all the high-order modes required for achieving EMD. To overcome this obstacle, cabling standard organizations determined that wrapping the reference cable a few times around a smooth, even cylinder called a mandrel can achieve EMD. So a question that comes up a lot in technical support calls is, why do I even need to use a mandrel? What happens if I don't? Well, cabling standards that specify mandrels have based the fiber loss used in link budget calculations on low-order modes only. If no mandrel is used, unwanted high-order modes will also be present, which will contribute to the overall loss measurement. So not only will the loss measurement include the low-order mode loss that is expected, the measurement also includes unexpected additional high-order mode loss. The net effect of not using a mandrel is that more loss is measured than the standard accounts for. Because of this, the loss measurement may indicate a failure, even if the link is perfectly fine to begin with. So the technician may end up wasting significant amount of time troubleshooting a perfectly good link just because they didn't use a mandrel. Since multimode fibers come in two common core sizes, each core size requires a different mandrel diameter. According to most popular cabling standards, the official mandrel diameter is 0.7 inches for 62.5 micron core and 0.9 inches for 50 micron core, each requiring 5 non-overlapping turns on the mandrel. Some companies have developed officially sized mandrels specifically for this purpose. Here's an example of a mandrel. However, if these specially designed mandrels are not available, it is also acceptable to use any smooth, even cylinder that is available as long as it is close to the official mandrel diameter. Wooden dowels or PVC pipes are suitable alternatives, since these materials are inexpensive and readily available at most hardware and home improvement stores, although they might not be perfectly the right size. The important thing to remember here is that you don't want the mandrel to be smaller than the official size, but slightly bigger is okay. For example, a standard wooden dowel size is 0.75 inches. Since the diameter is slightly bigger than 0.7 inches, simply give the mandrel a couple extra wraps to achieve the same effect. The mandrel should be long enough to accommodate 5 to 7 turns. 3 inches is usually sufficient for a 1 meter reference cable. important to make sure that the turns do not overlap, and the turns should be snug around the mandrel, but not pulled tightly. Okay, in this example, we will be wrapping a 1 meter 62.5 micron multimode reference cable around a 0.75 inch wooden dowel, and we will need some electrician's tape to secure the patch cable to the mandrel. Now, simply hold the mandrel in your hand and leaving about a foot of pigtail so you can have a connection to the test equipment, and you simply wrap around 7 times. So 1, 2, 3, 4, 5, 6, 7 or so, and remembering we want the wraps to not overlap, but be snug to the mandrel and not pulled tight. So holding the mandrel or the patch cable in this position, simply cut off a section of electrician's tape and begin securing the mandrel or the patch cable to the mandrel. Now, the reason we want to make sure that we secure the patch cable around the mandrel is that once the cable is wrapped around the mandrel, if you let it unwrap, this will change the reference level as you're doing your testing. So we want to make sure that we have this electrician's tape nice and snug so that the patch cable is fully wrapped around the mandrel and it doesn't come unwrapped. The mandrel wrapped cable will be attached to the fiber optic light source during all phases of an insertion loss test, from setting an optical reference or zeroing all the way through until all the fibers have been tested. 2 key things to remember once the optical reference has been set. First, do not remove the reference cable from the light source, and second, do not unwrap the reference cable from the mandrel. In fact, it is recommended to leave the reference cable wrapped around the mandrel until the reference cable itself needs to be replaced. To learn more technical information about mandrel wrapping and EMD, a wealth of information about this subject can be found on the internet or from fiber optics training courses. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more instructional videos, or to learn more about OWL's products in general, please visit owl-inc.com. I'm Professor Jim Powers. Thanks for watching.